Okay, hello everybody. We are moving forward into our polynomials in 3.2, looking at higher degrees, higher than 2, so we're going to get out of our quadratics into our quartics and quintics and all those fun words, but sadly that's the only two, quartics and quintics. We don't actually have words for the other bigger degrees. We just say 6, 7, 8, 9th degree polynomial. Pretty boring, but that's okay. The graphs are pretty interesting. So the polynomial functions, the graphs of polynomial functions, there's one big word that goes with this, and that is the word, oh good, I'm pretty sure every single one of you said continuous, right? The continuous word meaning it is smooth, has rounded turns, and by rounded turns that means there's no corners, so there's no sharp turns on any polynomial function. So I don't ever want to see a sharp turn on any of your sketches of graphs. And there's also no breaks. And what that looks like is this, as soon as I pull this up here, this is the things on the left there could be graphs of polynomials. The one on the top there, the polynomial is probably a quadratic. Could be a quartic, could be something to the sixth power, but that just depends on the function itself. And as you go down, notice that the sketches are pretty smooth. They're all rounded corners. There's nothing sharp. A non-polynomial function, the stuff on the right here, this one here is our absolute value function. This one is probably a piecewise function. Notice this has a break in it. There's a jump. Even though the rest of the graph is smooth, that jump makes it so it's not a polynomial. Remember, we're just strictly looking at polynomials in this particular chapter. The first section being that quadratic stuff that we did the previous lesson. Okay. So we move on to looking at functions or looking at polynomials by degree. If you have an even degree polynomial, that's our quadratics and our quartics, or our second and fourth power polynomials, and our sixth degree, or 8th degree, or 10th degree, etc., etc. The end behavior, so what's happening on both sides of the function, is it's both up, so it goes up, up, or opens up, like we did talk about our quadratics, if a is positive, and it goes both down if a is negative. And you have to remember that a is our leading coefficient of the polynomial, the number in front of the biggest degree. And for odd degree polynomials, linear, cubic, quintic, 7th, 9th, all that sort of fun stuff, the end behavior is down, up. So down on the left, up on the right, if a is positive, and up on the left, down on the right, if a is negative. I'm going to look at what that looks like here in just a second. Not that, obviously. Okay, so just kind of sketch a couple things here. If we have an even function, even polynomial, even degree polynomial, if a is greater than 0, we're going to be both up. So there's an example of a quadratic. Even degree, leading coefficient is positive. Here is an even degree with leading coefficient negative. And any other variation where they're both going in the same direction. Doesn't matter how many squiggles you have right there, and I could do a whole bunch of squiggles here as long as they're smooth. And oops, let's go this direction because it's got to be negative. That direction. That line doesn't exist. Okay, obviously. And then for odd, this is for when a is greater than 0. It goes up, down on the left, up on the right. And vice versa for an odd degree with a is less than 0. And again, you can kind of just add as many squiggles as you want in the middle, as long as you have end behavior going in opposite direction. And so on and so forth. It doesn't matter however you draw it. You can draw as many of those as you want. But what we like to talk about is what in behavior, how we actually describe in behavior in words. We actually don't do it in words. We actually do it in kind of symbology, using some symbols here. So we say, as x approaches infinity, or as x goes to infinity, that's what that statement says, f of x, or the function, what's happening to the function. So here, oops, as x goes to infinity, as x goes to the right, f of x is going up to positive infinity. And likewise, as x goes to negative infinity, so going towards the left, f of x goes to positive infinity as well. And we can just kind of fill this out. As x goes to infinity, f of x goes to negative infinity. As x goes to negative infinity, f of x goes to negative infinity as well. Now, you notice the difference here as you get to odd functions. As x goes to infinity, f of x goes to, well, infinity as well, because we're going to the right. From the middle, we're going to go to the right as x goes to infinity. But as x goes to negative infinity, going to the left, this is where f of x goes in the opposite direction, so negative infinity. And filling this out, as x goes to infinity, f of x goes to negative infinity. And as x goes to negative infinity, f of x goes to, where are we going? Positive infinity. Okay, so that's kind of how we describe in behavior. And we can kind of describe that given an individual function, which is what I have here at the bottom here. We can just look at functions and automatically know their in behavior. Because this is an even degree and a is positive, that means as x goes to infinity, f of x goes to, well, infinity, because it's even, which means it's going to go up, up. It's even and it's a positive right here, so it's going to go up, up. So we also say as x goes to negative infinity, f of x goes to negative or positive infinity as well, because it goes in the same direction. And we're going to use this a little bit later, just saying, hey, it goes up, up. This is just helping us to graph when we get to the graph. And then likewise, we can look at this. This is an odd degree. A is positive, and therefore it's going to go, just to help us out, it's going to go down on the left, up on the right, which means if we make our statement, it says as x goes to infinity, f of x, sorry about that, goes to infinity, and as x goes to negative infinity, f of x goes to negative infinity as well. And we basically just take that straight from that other page that we just filled out on the back here. All right, so let's go ahead and move forward. Let's start looking at better graphs, I think, or more fun graphs, right? Everything's more fun once you get a little bit more challenging. And we're going to sketch some graphs using our zeros of our function, just like we do with quadratics. We're going to use zeros, which are our x-intercepts, to help us sketch the graph. And here's the things we need to find. We need to factor and find all our zeros. We need to determine the in behavior. And we needed to determine the y-intercept. That way it'll help us sketch our graphs, which is what we're going to do afterwards. Okay, so these are all the really important pieces, and they always have been. I mean, this is exactly what we do for quadratics as well. We determine if it opens up or down. We determine its zeros. We determine, for quadratics, we determine vertex, but for polynomials, we can't do that yet. You have to know a lot more stuff in order to do that. Before I go to examples, though, I'm going to say one more thing about our multiplicities. You remember the word multiplicity from last year? It means how many zeros you have at a certain zero, at a single zero. If you have an even multiplicity, so you have 2 or 4 or 6 zeros at one number, then it bounces off the x-axis at that point. And we actually say it actually looks like a parabola at that point. And then if it's an odd multiplicity, then the function squiggles through that point. We just use a really general term there, squiggles. And it actually looks like a cubic right there. So we have a few examples that are going to be like this. The first two, we're going to sketch straight from the polynomial function itself. So we're going to find some zeros. So here's our examples. We have f of x and g of x. Notice I already have my axes ready. There was no way you knew what was going to come, so sorry, you got to draw all this stuff. For f of x, what I want to do first is I want to factor. And some of you might think that that's not factorable, but we have a 2 here and an x here, and a 2 here and an x here. That means they both have a negative 2. I'm going to take the negative out. I don't like leading negatives. And I'm going to take the x squared out because they both have an x squared, which leaves me with an x squared minus 1. And that's nice for us because x squared minus 1 factors again to x plus 1, x minus 1. Now, when we graph our polynomials, there's a lot of just little basic beginning work stuff that we need to do. So we need to figure out what our zeros are. In this case, it's 1, negative 1, and 0. Don't forget the 0 out here. This x out here creates an x-intercept. And it's actually, it creates two x-intercepts because it's 0 multiplicity 2 because it's x squared. The y-intercept is when I plug in 0 for x. And if I plug in 0 for x, I actually just get 0. And I want to look at end. So don't forget this, end behavior. Don't ask me tomorrow what this is, because that's what I said, end behavior. All right, so in behavior, because it's a quartic, it's either up, up, or down, down. But because it's a negative quartic, it's going to be down, down. So that's kind of what our in behavior is going to look like. So let's go over and sketch our graphs, or our graph. We have a 0 at negative 1, a 0 at positive 1, and a 0 at 0. And I know my in behavior goes down and down. That's just to help me guide, right? And speaking of multiplicity, as we mentioned a minute ago, it's a multiplicity 2 at this 0. So when I come up through this point, and which means I actually have to come up through this point too, notice it's kind of hard to think about. If I tried to go straight through this 0, there's no way I can reach that upper point. Or vice versa, if I went down this way, there's no way I can reach that line without crossing the x-axis. And this is why we think about the bounce. At this particular 0, it bounces to make it look like a quadratic right there. And if you were to zoom in, that little spot right there looks kind of like a quadratic. Okay, it bounces off that 0. And there you go. There's your graph. So if we move to our second example in this form, some people kind of look at this sometimes and say, well, this doesn't factor either because it's a quartic, and I don't know how to factor that. But we've worked a couple of these before, and we notice that this is a 4 and a 2, which actually means it factors just like a quadratic does. But instead of linear x's right here, we get quadratic x's. And then we just look for two numbers that satisfy our normal two things to multiply together to get 4 and add together to get negative 5. And that is negative 4 and negative 1. Well, that's actually nice for us as well because this is x plus 2, x minus 2. And this is x plus 1, x minus 1. We knew that already because we already did it. So now that we're factored, we can find our zeros of 2, -2, 1, -1. Our y-intercept is when we plug in 0 for x, so we get the point 0, oops, not 0, 0 this time, 0, 4. End behavior, it's a quartic, and it's positive, and therefore it's up, up. And I seriously do want you guys to get to being this quick at sketching these type of graphs. I know I've done this a lot. I've taught people how to do this, but really this is kind of how fast I want you guys to be able to do it. Factor pretty quick. I know some of them get a little bit more challenging, but as soon as you factor, I want you to be able to find the zeros instantly. I want you to be able to find the y-intercept instantly by plugging in 0 for x. And I want you to instantly find the end behavior just given this first term. Okay? And then the sketch, once you have all that, the sketch is easy. Okay? So we have zeros at -2, -1, 1, and 2, and a y-intercept of 4. And I just realized I put my work right in my way, but we can go over that. I know that it goes up, up out here, so I have to follow my lines, or follow my dots, connect the dots here. If I go down, I have to go up through that point. It has to go way up to the 4, down through that 1, up through that 2, and through my work this direction. And notice there you have your graph. Okay. What else do I have here for us? I have one more example for us. Oh, just realized I do have one more example before I can go to the assignment for you guys. One more example is, hey, what if I just gave you some zeros and I told you to find a polynomial? Well, this is just going in the reverse order. We always found our zeros by looking at the factors. So I'm going to create factors. I have x minus 1 to make that a 0. I need an x minus 3 to make that a 0. And I need an x plus 2 so I can make the -2 a 0. And then from there, I don't want polynomials in this form. I want polynomials in standard form, which means I need to do a bunch of multiplying and foiling, your favorite. X squared, if I FOIL these first two, don't try to randomly do all three at the same time. It doesn't work. Okay? You must do two at a time. So I get x squared minus 4x plus 3, and then an x plus 2. And this one's a little bit harder to multiply, so I'm just going to take this x squared and multiply by the other two. So x squared x cubed plus 2x squared. And I'm going to take the minus 4 and multiply by both. So I get minus 4x squared minus 8x. And then I'm going to take the 3, multiply by both. I get plus 3x plus 6. And then I'm going to simplify. I get x cubed minus 2x squared minus 5x plus 6. And eventually, over the next few days, maybe this week sometime, actually definitely this week sometime, we'll be able to look at this function and be able to factor it down so we can find our zeros. But you guys probably don't remember how to do this just yet. We'll get to that a little bit later. I think that's our 3.4 if I remember correctly. Okay, so that's pretty straightforward. I think every one of you guys can do that. Doesn't matter what grade you got for me. I'm pretty sure you guys can do that. Okay, so here's our assignment. Looks a little bit different than normal. The long piece at the top there is your assignment that is for you to do, to review, and make sure you know what you're doing. The assignment in bold at the bottom, that's what's due to me by the end of class. So that is 11 problems. If you started it sometime before we got to class, then there wouldn't be as much to do. But like I said, it's kind of one of the things that we just got to start working on. And I want those 11 problems due to me at the end of class. Okay? So thanks for watching. Let me know about any quality issues, any other issues that you might have had for the video. just kind of let me know. You can let me know in the comments. You can let me know on email, however you want to do it. Okay, have a good time doing the math. Learn some stuff. Show me what you know. All right? Thank you. Goodbye.